Welcome back to my channel. For this video, I will discuss solving logarithmic equations applying laws of logarithm. Kung bago ka lang sa aking channel, mag-subscribe ka na. Hit mo na rin ang notification bell para updated ka sa mga susunod ko pang mga math videos. At syempre, para tuloy-tuloy din ang iyong pag-aaral. Let's start by the following definition of terms. Common logarithms are logarithms with base 10. Log x is a short notation for log of x with base 10. Next, natural logarithms are logarithms to the base e and are denoted by ln. Ln x is another way of writing log of x with base e. Laws of logarithm are rules that allows logarithmic expressions be written in different ways. Let's now discuss the laws of logarithm. Law number 1. The logarithm of mn with base b equals log of m with base b plus log of n with base b. This is called the product rule. Since logarithmic function is the inverse of exponential function, or logarithm is another form of exponent, therefore, the product rule of logarithm is pattern to the law of exponent x to the m times x to the n equals x to the m plus n. Examples, log of 6x to the base 4 equals log of 6 with base 4 plus log of x with base 4. Next, log of 8x squared y with base 2 equals log of 8 with base 2 plus log of x squared with base 2 plus log of y with base 2. Third example, log of 4 times 5 with base 7 equals log of 4 with base 7 plus log of 5 with base 7. Law of logarithm number 2, log of m over n with base b equals log of m with base b minus log of n with base b, called the quotient rule. And it is also pattern to the law of exponent x to the m over x to the n equals x to the m minus n. Examples, log of m over 3 with base b equals log of m with base b minus log of 3 with base b. Another, log of 64 over 9 with base 4 equals log of 64 with base 4 minus log of 9 with base 4. Third, log of 8x all over y equals log of 8 plus log of x minus log of y. This is a combination of law number 1 and law number 2. Law of logarithm number 3. Log of m to the k with base b equals k log of m with base b, or called the power rule. This law is very simple. Just convert the exponent as coefficient. Example, log of x cubed with base 6 will become 3 log of x with base 6. Again, the exponent 3 become coefficient. Next, log of 9x cubed with base 6 equals log of 9 with base 6 plus 3 log of x with base 6. This example is a combination of laws 1 and 3. Next example, the logarithm of quantity 8x over y to the 5th equals 5. Quantity log 8 plus log x minus log y. This example is a combination of product, quotient, and power rules of logarithm. Law of exponent number 4. Log of 1 with base b equals 0, or called the zero rule, meaning the logarithm of 1 in any base is always 0. Once again, it is pattern to the law of exponent x to the 0 equals 1. Like for instance, log of 1 with base 12 equals 0. Log of 1 with base 4 equals 0. And log of 1 with base p equals 0. Law of logarithm number 5. Log of b with base b equals 1, or called the identity rule. Very simple. If the value and the base are the same, it is always equal to 1. Examples, log of 8 with base 8 equals 1. Log of 10 equals 1. It means log of 10 with base 10. Log of 65 with base 65 equals 1. We will now apply that laws of logarithms in solving logarithmic equations. Number 1, we have 2. The logarithm of 3x with base 5 equals 4. To solve for this, since we have common 2 and 4, we will first divide both sides by 2. So 2 is cancelled. So we have log of 3x with base 5 equals 4 divided by 2 is 2. Since logarithm is the inverse of exponential function, we will change this new logarithmic equation into exponential function. The base is 5, the exponent is 2, and the power is 3x. They are the same. They are inverses with each other. 5 squared, 5 times 5 is 25 equals 3x. To remove 3 from x, we will divide both sides by 3. So we have x equals 25 thirds. In this first easy example, laws of logarithm is not yet applied. Only the inverse of logarithm, the exponential function, is applied. In number 2 problem, we have the logarithm of 27 with base 3 plus the logarithm of 343 with base 3 equals x. To solve for this, we will now apply the properties of logarithm. Number 1, change 27. 27 is also 3 cubed in exponential form. 343 is 3 to the 5th with base 3. Okay. Then, 3 and 5 are exponents, so we can apply the power rule. The power rule is we have 3 log 3 with base 3 plus 5 will become coefficient in power rule of logarithm. Log of 3 with base 3 equals x. Then another property can be applied. If the power and the base are the same, we can apply the identity law. So it is 1. Same base, same power, it is also 1 equals x. 3 times 1 is 3. 5 times 1 is 5. So, our x, or the answer in our logarithm, is 8. Another way of solving number 2 is applying the product rule. The product rule is we have log of 27 times 343 with base 3 equals x. So we have log of 3 cubed is 27, 3 to the 5th is 343 with base 3 equals x. Log of 3 cubed times 3 to the 5th is simply add the exponent. 3 plus 5 is equal to 3 to the 8th with base 3 equals x. Then apply the power rule. So we have 8 log of 3 with base 3 equals x. Then apply the identity rule. So we have 8 times 1 equals x. X times 1, 8 times 1 is equal to 8. So we have the same answer. Number 3 problem. Log of quantity x plus 2 with base 2 plus log of 6 with base 2 equals 3. Since we have addition, we will apply the power rule. So we have log of x plus 2 multiplied to 6 with base 2 equals 3. So we have 2 cubed The base is 2, the exponent is 3, is equal to x plus 2 times 6. 2 cubed is equal to 2 times 2 times 2 equals 8. 6 times x is 6x. 6 times 2 is 12. Then combine like terms. We have 8 transpose 12 will become minus equals 6x. 8 minus 12 is negative 4 equals 6x. Let us copy first. To remove 6, just divide both sides by 6. So we have x. Common divisor is 2. 4 divided by 2 is 2. 6 divided by 2 is 3. So we have negative 2/3 as our x. For our problem number 4, we have 2 log of x with base 3 minus log of quantity x minus 2 with base 3 equals 2. So we will apply the appropriate laws of logarithms. Since we have the coefficient 2, we can apply the power rule. So we have log of x squared with base 3 minus, copy first, log of x minus 2 with base 3 equals 2. Then since it is minus, we can apply the division rule. So we have log of x squared all over x minus 2 with base 3 equals 2. Next, change it into exponential form. So we have 3 squared equals x squared all over x minus 2. 3 squared is 9 equals x squared over x minus 2. Since we have imaginary one here, by cross product, 9 x minus 2 equals x squared. 9 times x is 9x. 9 times negative 2 is negative 18 equals x squared. Since we have x squared, we can isolate all the terms in one of the two sides. So, since the x squared is on the right side, we will make 0 the left side. So, we have x squared. Transpose 9x to the right will become negative 9x. Transpose 18 to the right will become positive 18. Then, apply factoring. X squared is x and x. Positive last term, negative. So, we have minus and minus. What are the factors of 18? If multiplied, is 9. So we have 6 and 3. Sorry, what are the factors of 18 if added equals 9 are 6 and 3. Okay, next, apply zero product property. X minus 6 equals 0. X minus 3 equals 0. So we have x equals, x equals transpose positive 6. X is equal transpose positive 3. So we have two possible answers, 6 and 3. To determine if 6 or 3 or both of them are the solutions, we need to substitute that or to check on the original logarithmic equation. So we have 2 log of 6 with base 3 minus log of quantity 6 minus 2 with base 3 equals 2. Okay, we have, applying the power rule, we have log of 6 squared with base 3 minus log of 6 minus 2 is 4 with base 3 equals 2. Okay, so applying the quotient rule. So we have log of 6 squared over 4 with base 3 equals 2. 6 squared is equal to 36 over 4 with base 3 equals 2. Next, 36 divided by 4 equals log of 9 with base 3 equals 2. 3 squared equals 9. Make it exponential function. 3 squared is 9 equals 9. Therefore, 6 is a solution. To check if 3 is also a solution, substitute. We have 2 log of 3 with base 3 minus log of 3 minus 2 with base 3 equals 2. 2. Identity law, so we have 2 times 1 minus log of 3 minus 2 is 1 with base 3 equals 2. 2 times 1 is 2 minus, this is 1, meaning this is 0, law of 0, so we have 2 minus 0 equals 2. 2 minus 0, 2 equals 2. Since this is equal, therefore 3 also is the solution. Therefore, we can now say that in number 4, the values of x are 6 and 3. Okay, number 5, we have log of 2 with base 5 plus 2 log of x with base 5 equals log 18. So apply the property, copy first, no law to apply, plus since we have coefficient, we can apply the power rule. So we have log of x squared with base 5 equals log of 18 with base 5. Since the left side is addition, so we can apply the product rule. So we have log of 2 times x squared with base 5 equals log of 18 with base 5. Again, if you are familiar with the inverse or the property of inverse function, if we have the same exponent, therefore we have the same base. So we can say now that 2x squared is equal to 18. Divide both sides by 2. So x squared equals 18 divided by 2 is 9. Extract its square root. The square root of x squared is x. The square root of 9 is plus and minus 3. Now, again, we have two possible values of the solution. It can be positive 3 or it can be negative 3 or both. To check, we will first substitute positive 3. So we have log of 2 with base 5 plus 2 log of 3 with base 5 equals log 18. Log of 2 with base 5, we have the power rule plus log of 3 squared with base 5 equals log 18. Again, since this is plus, we can apply the power rule or the product rule. So we have log of 2, 3 squared is 9 with base 5 equals log 18 with base 5. 2 times 9. Log 18 with base 5 equals log 18 with base 5. Very obvious. They are equal. Therefore, positive 3 is a solution. How about negative 3? Let us also try negative 3. So log of 2 with base 5 plus 2 log of negative 3 with base 5 equals log 18. Log 2 with base 5 plus log negative 3 squared by power rule with base 5 equals log 18. log 2 with base 5 plus log of negative 3 squared is log 9. 3 times 3 is 9. Negative times negative is positive. Apply the product rule. So we have log of 2 times 9 with base 5 equals log 18. 2 times 9 equals 18. 18 equals 18. Again, it is correct. Therefore, negative 3 is also a solution. Since both of them are solutions, we can now say that in number 5, the value of x are positive 3 and negative 3. Kung nakatulong at nagustuhan po ninyo ang aking video, please like. At kung gusto rin po natin makatulong sa iba, i-share na rin po ang aking video.